This video lecture is meant to cover the information found in Chapter 2, Sections 2 and 3. And in this video lecture, we will be going over objectives number 7, 8, and 9, which are to define and classify matter, pure substances, and mixtures, to state the definition of and differentiate between an element and a compound, and to define and classify homogeneous and heterogeneous mixtures. So first we're going to take a look at mixtures, classifying mixtures. A mixture is a physical blend of two or more compounds, or could be two or more elements, or some combination of compounds and elements. Now when you have a mixture, they can either be mixed unevenly or that mixture can be mixed evenly. If you have an uneven mixture, this is what we call a heterogeneous mixture. Okay, there is, basically you can tell, you can see by looking at this substance if it has more than one substance in it. Okay, so what we have here is a fruit salad. You can clearly see the different parts of the fruit salad. So here we don't just have compounds and elements, we have food pieces that are clearly mixed unevenly together. You can see all the parts. Here in this small picture here you can see oil and water, or maybe it's oil and vinegar, it's hard to tell, but you can clearly see that these are two substances that are not mixing together. You can see the parts, so you know that this is a heterogeneous mixture. Now the question will be how many phases? This is effectively how many parts can you see to the mixture. So to have a heterogeneous mixture you have to see two or more phases. This diagram here, this picture, is two phases. And the fruit salad is many, many phases, many different pieces to the mixture. A homogeneous mixture in chemistry, a synonym for this is a solution. If we are talking about a solution, we are talking about a homogeneous mixture. A solution is when you start with water and you add stuff to it, to the water, and the stuff that gets added to the water gets dissolved. Okay, so a solution is a homogeneous mixture. The composition is uniform, it looks even, and in fact it looks like there's only one phase. It looks like there's only one thing. You can't see all the things that are in that solution. Okay, taking a look at some possible liquid examples, you could have vinegar. Vinegar is water and acetic acid. Now, the picture I have here of a liquid solution is, well, this is a solid dissolved in a liquid, but this is a liquid solution right here of Kool-Aid. A gas solution, the air that you breathe, yes, it has oxygen in it, but it also is mostly made up of nitrogen gas and carbon dioxide gas and some water vapor. Okay, but to look at air, it doesn't look like there's more than one thing in it. All you see is one thing. A solid solution example is stainless steel. Stainless steel looks like one kind of metal, but in fact there is iron, there's chromium, and there is nickel in that metal. Okay, so homogeneous mixtures look like it's just one thing. You can't tell that there's more than one thing in it. So if you have a mixture, you should be able to separate that mixture physically. You should be able to use the physical properties of the substances in that mixture to be able to separate the components. Typical ways in chemistry to separate a mixture is through filtration. Here's a picture of a solution or substance being filtered through a piece of filter paper. Okay, so filtration is a process that separates a solid from the liquid in a heterogeneous mixture. You would pour the mixture into a filter paper cone. The solid can't get through the filter paper and the liquid goes through. So therefore you have a separation. The solid is left behind in the filter paper and the liquid goes through. Separation, physically done. Distillation is a process that separates two liquids that are in a homogeneous mixture. So if you have two liquids mixed together, you can separate them assuming that those two liquids have different boiling points. What you would do is you would put that impure, that mixture, into this flask right here and you heat it up to the point where it's boiling. Well, of the two substances that are in there, the substance with a lower boiling point will evaporate first, and then that first gas will come down here. The only place it can go, it's trapped here, there's a cork here. So that vapor has to go down through this condenser, right? This just has cold water flowing on the outer jacket of this tube, so that all of a sudden that hot vapor must condense back into a liquid, and then that first liquid that boils off is collected here. So that's what's called the distillate, or the distilled liquid. Okay, so what you would do if we're writing down these notes, you would heat the mixture until the liquid with the lower boiling point boils first. You collect that vapor and condense it into a pure liquid, and the other liquid is left behind. So you end up with the substance with the lower boiling point in this flask and the substance with the higher boiling point left behind in this flask. So filtration and distillation are two different ways to separate mixtures based on their physical properties. Section 2.3 is learning to distinguish between elements and compounds. We referred to elements and compounds in our last lecture as substances. In this course, if you use the word substance, or if you hear the teacher use the word substance, we are referring to it as either an element or a compound. Right? So defining what an element is is the simplest form of matter that has a unique set of properties. And a compound is a substance that contains two or more elements chemically combined in a fixed proportion. So let's take a closer look at these two terms in these pictures. This first picture right here, my diagram shows these as red, right? These are atoms of an element. Okay, so this is an element that is made up of single atoms. Notice that each one of these atoms of this element are identical. They're exactly the same. So this substance would have a unique set of properties different from every other element. Now, here is, in the second picture, this is also an element, even though these elements are made up of two atoms stuck together. But notice, in this particle, there are two atoms that are identical to one another that are bonded together. Okay? So this is also an element because each one of these particles is exactly the same as each other, and each particle is made up of atoms that are identical to each other. So these are what we call molecules. Each one of these particles is called a molecule. But these molecules, because they are made up of the same atom, this second box here is also an example of an element. So an element is where each particle is identical to all the other particles in that sample. Now, the molecules of a compound, okay? This next picture is a compound. If we look at each one of these particles, they are identical to each other, but notice that these particles are made up of two or more atoms. Okay, so here we have three green and one purple atom stuck together to make this particle. We call this a molecule. Okay, this is a single particle. In this case, is called a molecule because you have multiple atoms stuck together. But collectively, this sample is referred to as a compound because the particles are made up of atoms that are not the same to one another. Okay, so this is a compound because the particles are made up of atoms, multiple atoms that are not the same to each other. These pictures represent elements because you have each of the particles are identical to one another and they are made up of atoms of the same type. Okay. Elements cannot be broken down. You cannot take these elements, either this first one or the second one, and chemically break them apart. Okay. Compounds, however, can be broken down into simpler substances by a chemical means, by chemical process. Okay, so this is a key concept here that you definitely need to embrace. You could take this compound right here that I'm circling, and you could do a chemical reaction and separate the green element from the purple element. Okay, so that's a compound. These elements, you cannot do anything to them to separate into simpler substances. All right, so breaking down a compound. To do this, you need a chemical change. Okay, remember we said a chemical change is a change that produces matter with a different composition, a different identity from the original matter. Properties of compounds will differ from the properties of the component elements. So, for example, water is H2O. That's two hydrogens and one oxygen. The properties of hydrogen and oxygen separately are very different than the properties of water. Distinguishing substances from mixtures. Remember, substances, are what we would refer to as elements or compounds collectively. And if you are talking about an element or a compound, the composition of that material is fixed. However, a mixture, the composition of the material varies, and we can say that that mixture is either homogeneous or heterogeneous. Okay. And so that's one way to distinguish between substances and mixtures. The last section of this part of the chapter is distinguishing between symbols and formulas. A chemical symbol represents an element. You've learned some of these: hydrogen, oxygen, carbon, magnesium, copper, lead. Okay, those symbols represent elements. A formula, a chemical formula, represents a compound. So for example, H2O, written like that, that's not just hydrogen and oxygen, that's 2 hydrogens to every 1 oxygen, which is of course the water molecule. Here's another chemical formula, C12H22O11. If you take 12 carbons, 22 hydrogens, and 11 oxygens, and you stick those together with a particular type of bonding, you will have a sucrose molecule. That's table sugar. Okay, so these are chemical formulas, and they represent a molecule of a chemical compound. This concludes the video lecture on mixtures and elements and compounds. We'll see you in the classroom.